About a year ago, I did a video on a speed control that used a $35 Pi and a companion $25 display. At the time, both the Pi and the display were just laying around, so for me it was a no-cost build. Then, this past summer I started working with the Arduino platform where it was the main controller for a series of balance bot projects that I was pursuing. Along the way, the Pi found a new full-time job as a streaming internet radio receiver, and, if truth be told, using the Pi as a CNC speed control is the equivalent to killing flies with a cannon. But once you have one, running a CNC machine without it is no longer an option. So, armed with the knowledge of what an Arduino could do, I found a $10 Leonardo clone and a matching $6 display, and ported the Pi C code over to the Leonardo. I think this new version performs even better than the original, and if you're starting from scratch at a third the cost, it's a no-brainer. YouTube is rich with Arduino videos, but as a CNC speed control, I didn't find many examples. So even though this repeats a lot of what was done last year, I hope you'll find it's worth another look. We've been watching the main components that come into play when the G-code commands the spindle to start and stop. But now let's take a look at a sketch of this system to get a better feel of electrically what's happening here. Starting at the top, the box labeled SSR represents a solid-state relay. This relay is controlled by the same G-code and software that's running the CNC machine. It switches the 120 AC to the 48-volt converter. The output of the converter is connected to a Chinese speed control that, if you don't already have, can be found on eBay for about 14 bucks. Mine came bundled with the motor and mount that you see in this video. From the speed control, a PWM modulated version of the 48 volts goes to the motor, which is shown in the diagram at the bottom of the page. Now the Leonardo's interrupt pin, DP3, is connected to the output of the reflective IR sensor. And for what it's worth, checking the internet, I found it on eBay today selling for about $5. Each time the motor completes a revolution, the white stripe at the top of the motor will cause this sensor to pulse low. The Leonardo's interrupt service routine measures the average interval of the pulse stream, and based on that, the Leonardo, using a classical PID algorithm, corrects the duty cycle of the 5 kHz PWM signal, digital pin 11. That goes to the speed control. This causes the motor to speed up or down as needed to keep it rotating at the target RPM. The WZ version of the sensor comes with wire leads already attached, and the LCD display comes pre-assembled. So other than your specific mounting needs, this is an easy upgrade. In my case, I currently have the passive components, the 2 resistors and 1 capacitor, mounted on a small prototyping board. But these components could have easily been mounted in line as part of the cabling going to the sensor. But again, that can be your call. Now, let's energize the Leonardo and see how long it takes it to get up and ready to go. Just seconds. And unlike the Pi version, shutdown is just as simple because there's no need to worry about interrupting a background process that might be changing a config file. The final segment of this review will focus on how the Leonardo has been programmed to display various operating conditions and how it interprets user input via the keypad. What you're seeing now is the default mode, Spindle startup and shutdown sequence. That is, on the top line it shows the target or user set speed, and on the second line it shows the actual measured spindle speed, or it reads ready if it thinks the spindle is not turning at all. Normally, I'd press the buttons with my finger, but for these shots, I'm using a screwdriver in an effort to make it clearer which button is being used to get the resulting effect. But because of the relatively low light levels, it's not showing up as well as I had hoped it would. So to summarize, here's what's going on. Pressing either the left or right buttons allows the user to sequence through the various display modes, and they are the default, the actual running speed, running era measured to the revolution, duty cycle, and that's a PWM percentage, and a bar graph view of the PWM percentage. While the up and down buttons will increment or decrement the set speed in 200 RPM steps over the range from 1400 RPM to 10,000 RPM. Now, while we're in the bar graph mode, watch the change that the PWM cycle undergoes as the target RPM is increased from a few thousand RPM to 10,000 RPM. The Chinese speed control clearly does not produce a linear relationship, yet the Leonardo's PID has no problem negotiating this non-linear demand and remains stable over its entire range. Well, that's about it for now. As always, good luck with your next project, whatever it may be, and thanks for watching.